Welcome back. Our next speaker builds circuits that generate waveforms that kind of mimic things that are found in nature. She's really interested in machines relating to nature and nature relating to machines. She's going to be talking about analog circuits that she's designed that mimic animal sounds. Please welcome to this Hackaday Super Conference stage, Kelly Heaton.
Hi, everybody. Thank you so much for being here. It's such an honor to get to address an audience that understands what I do in my art. So I am a fine artist. I come from that background, but I'm fascinated with the spark of life and with electricity as a medium. I think that of all the media in our culture today, electricity is absolutely the most important. It is the tool that has changed civilization so radically that it's precipitated a new geologic era, right? The Anthropocene, because with electricity, we're just that powerful. So as an artist, I feel like, wow, this is something I want to dig my teeth in and be able to work on. And then also, before I get started here in my slides, I just wanted to read a quote from my favorite electronics teacher, Forrest Mims. Many of you probably know him. This comes from an email dialogue that I had with Forrest, where he said, analog electronics parallel living organisms while programmable logic merely simulates life. And that's something that I really believe in, and as you'll see coming up here in my slides, I've tried to dig into in my practice. But before I get into my electronic work, I wanted to show you a couple of images created by artists who've inspired me throughout my career. And the depictions, like of the Charles Birchfield image here on the left, is an effort by a visual artist to represent electricity, right? It has this wonderful vibratory quality, and of course I think that's also the success of Van Gogh's paintings, is that we can just feel them vibrating, like we can almost see the electricity in them. And then the other image I included is from Audubon, because he just had this intense observation of nature, and that's something that I carry on into my practice. So these three images are from my work, and they represent different facets of the kind of work that I create. The large image is a watercolor painting of a cricket with an analog electronic circuit built into it that chirps like a cricket. And then in the upper top corner is one of my analog electronic songbirds that is folded out of transparent mylar, and inside of the songbird you can see visibly the analog electronic circuit that generates the song of the bird. And then a PCB detail of a piece called Pretty Bird that chirps sort of like a Carolina wren. So I want to say, before I move on here to play this video for you, this is going to show you a little bit so you can hear the sounds of what I'm creating, what my circuits are actually doing. I just want to say that everything that you're hearing is entirely generated by discrete component analog electronic circuits. There are no audio recordings, and I don't use software. So this is really hardware art. So here we go. The center element that you see there with all the wires coming out of it, that's actually my analog electronic sequencer board. So the reason why you're not hearing like the crickets or the other sounds going constantly is because that board is turning them on and off, and I'll talk about that a little bit later. So now as I'm moving around this scene, you're seeing the individual sound generators that make noises very similar to what exists in my landscape in rural Virginia. So to move on from that, I'm going to show you another similar kind of work, but in this case, I'm looking at birds. And that mess of wires is, again, my analog sequencer. So that's what's turning the bird songs on and off, so they're not constantly going, because that'd be super annoying, right? All right, so jumping back in time, this is where I started. I have a kind of mixed background. I've always ever been a fine artist. I've always ever been a nature freak. I also had a hard time kind of figuring out like where I fit in because I really wanted to integrate art and science because I am both and I'm passionate about both. So in 1998, I went to the MIT Media Laboratory and didn't really have a lot of technical skills. So it was definitely like learning by the fire hose, but what I started with was taking apart things that other people had built, and I migrated, or I was attracted to, things that seemed lifelike. So this is the anatomy of a Furby. And I went on to make a piece, this is me standing at the Center for Advanced Visual Studies, looking at a large sculpture that I built with 400 reprogrammed Furbies, where I used the eyes and mouths as water molecules to make a piece called The Pool. And the Furbies would wake up and start chattering when you would stand in front of them. So this would literally reflect your image, and this was part of an overall installation I called Reflection Loop, built together with engineer Stephen Gray. So I'll play a short video. Sorry to blow you out of the audio there, but the sound of all those Furby motors mirroring your body really did sound like water. It was crazy. It was very cool. So as I said, I worked with an engineer, Stephen Gray, to reprogram all of these Furbies because I did not have the technical skills at the time to do it myself. I did go on and work independently on a show called Live Pelt, where I trapped 64 used Tickle Me Elmos on eBay and made a coat that giggles and quivers when you touch yourself. I love that work and I was proud of it, but I still felt like, you know, so I'm looking at these electronic creatures, I'm trying to kind of ask, you know, where is the spark of life? What does electricity mean as a creative medium? But I still did not have the skills to dig into it myself. And so I put this image up on the screen just to say, like, this is sort of me, like, in this fantasy world of, you know, I just want, you know, electronics and nature and electricity and nature, like, I just want to integrate it all. That was what I was really inspired to do. So I set out to teach myself analog electrical engineering. And this is kind of what happened. I built lots and lots of really bad circuits, okay? I'm sure some of you can understand or relate to that. And it was 10 years that I worked on doing this. And that led me, these are details, but I chose these details because I just wanted to show you how like heavily worked the surfaces were. This was for a show that I did called the Parallel Series, and hopefully you get the pun there, right? I was trying to like integrate electronics and painting, but as I was building my circuits to like blink LEDs or make cricket-like sounds, I would break as many of them, or actually many more of them, than I would successfully build. And so I used that detritus, just like leaves or mulch material, and like just worked it into the surface of the canvas and left it there because it was like a kind of a natural process in and of itself. It was imperfect, but so is nature, right? So it's like this growth process. But out of that, I also learned that indeed documentation is absolutely critical because I needed to be able to go back and repair these circuits or tweak them or build other circuits with similar qualities. So this was one of the first pieces that actually, let me play this little video here. It's kind of faint, but you'll hear this like bird crying in the distance, and then there's this annoying click. You hear that click? Oh, God, it drove me crazy. And so I wrote in the lower right hand, because, and I couldn't get rid of it because I wasn't a good enough electrical engineer to just build any sound I wanted to. Like, I had to work really hard to get an effect, and then, sometimes it wasn't perfect. But I had to let that continue to be part of my artistic practice because it's real, that's where I was. This is what I was doing. I was taking a lot of risks in my practice, and sometimes it failed. So I'm just going to read you a little quote from the lower right-hand corner. I said, "I'm pretty sure that this circuit contains unnecessary parts and possibly bad engineering. I do not aim for efficiency, but effect. Therefore, my chief complaint is the click between cries, which I was unable to resolve." And then I ended up by saying, "I need to document these circuits for my own sanity," which was true because by documenting them and then going on and building other things, that was how I was able to figure out, like, okay, where is that click coming from and how do I get rid of it, or how do I take this bird call and turn it into like a frog or whatever. As I began getting, better in my engineering skills, I moved on to building my own circuits. These were etched on a flexible substrate. I did them myself with ferric chloride at home, and made another one of these, what I call electroliers. So this was the first one that I made with the sort of soundscape of the nighttime in Virginia. And then from there I moved on to look at bees, and it was, partly because I wanted to look at just like a different insect, but also because I was really concerned about what's going on with ecology and the role that electricity and the empowerment of humans and how that's affecting our environment. I'll play you this little video. You can see. So what I did here was I wanted to make bees that were flying around. But I couldn't figure out how to make the bees miniature enough, so I suspended like little sculptural bees on this very delicate mobile, and then I had like tiny little motors that people use for RC planes, and I just suspended them within this like mobile matrix, and everything just kind of like jiggled and moved around and looked bee-like. The controller circuitry for the bees was in the piece of paper that is on the bottom underneath of the tree, and then the wires all grew up the tree and fed the bee structure, and that kind of thing really appeals to me because that's how, to me that's what nature looks like and feels like. You have this electricity just running through it, and I love that. And then the other images that I put here. So in my engagement with electrical engineering and all these different discrete components, spending so much time with them, they really took on personality for me as an artist. And it was like, I wanted to engage this theme of like electronics, being lifelike as they are, we're kind of becoming us, and that we're sort of becoming them. And so I made these large, like human scale electronic components and staged them in a New York gallery. Which sadly I'm not sure many people in my audience even like recognize them as such, but it made me feel good. I like them. So moving on from there, I wanted, again, like birds are more complicated than crickets and bees, for example. And so I was looking at other species of animals. This little guy here is a gray tree frog that I made. And the way that I did this was to paint a watercolor of the tree frog, and then again to build the circuit into the surface of the paper. And I love that mixture of the traditional fine art medium with the electronic media. So at this point, I was able to achieve some effects, and that was cool, but I was still really limited in what I could do. I still am really limited in what I could do, and so I wanted to look at like sounds from nature to say like, okay, when I'm listening to a bird, what exactly am I hearing? Like how can I get better at this? Like, what's the path for me to listen to that sound and look at that sound and then build it? And I don't come from an audio engineering background, so I don't know. Maybe like some of you have the answer to that. Please come up and talk to me afterwards. But so for me, this is sort of what I figured out. So looking at the structure of sound, like what is it? How do I think about it? And so first I ask myself, okay, like what's the basic structure that I'm hearing? And I'm sure many of you have listened to like waveform primitives. So you kind of know like that a sine wave sounds different than a square wave and a triangle wave and so forth, right? So I start there and I say like, what's the basic waveform? And then of course, what's the frequency or the pitch, like how high or low is it? How loud is it? And, and then what's the texture, right? Because, just basic waveforms are not particularly interesting. Like there's always some sort of texture overlaying it. And then finally, like what's the structure of it? So in the case of that gray tree frog, that kind of goes, that's the sawtooth wave overlaid on this sine wave with texture that's creating the envelope, and therefore you get that kind of more interesting sound with some structure to it. So how do I do this? These are a couple different circuits that I use all of the time. The one that's my absolute most favorite, and I use it all the time, is an astable multivibrator. I love it because it's so simple. You can build one just with like very low cost, easily available capacitors, resistors, transistors. If I break something, it doesn't really matter. I'm not breaking something really expensive. And what I do is I daisy chain them. So I have found that if I take, so one astable multivibrator oscillator, any oscillator, isn't very interesting because you're just going to get your LEDs going blink, 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 right? Back and forth. So, okay, that's kind of boring. Well, so what I do, and this is just a simple example. This is a circuit that's on my Hackaday page under Hacking Nature's Musicians, so you can go and play with this if you want to. But I'm using this simple example to show you like where I'm creating the tempo, the pitch, and then the filter amplifier. But just focusing on the tempo and the pitch, because those are my two oscillators that I have in this circuit. What I'm doing is for the pitch the oscillator, I'm just finding like one point in that circuit that I can control with another oscillator. I mean, it's really that simple. So I build these astable multivibrators, and then I say like, where can I find a point in this circuit that I can control from somewhere else? And I just keep doing that. And I found that if I build up like 5 oscillators that are connected to each other and controlling each other, I can get really, really complex sounds with a very, very low cost, easily available parts. So I'm just gonna like show you I take these videos of myself playing with my breadboard. You can watch them on my Vimeo page. And it's cool to see how much it changes with very minimal intervention. So I spend hours doing this, and that's how I figure out how to make these animal sounds. And if you go, like I said, on my Hackaday page, you can find some schematics and some basic guidelines, and anybody can do this. And you may not want to make animal sounds, but it's a great way to make, if you're a musician or you want to add sound effects, like, just build some like hardware oscillators and tie them together in different ways. And if you break something, it's no big deal. You just blown out like a 30-cent transistor. It's just, it's not that stressful, I guess. The other thing that I encourage you to play with is your speakers, because the design of a speaker matters tremendously in the sound quality. So this is just a little piezoelectric disc. I also have instructions on my Hackaday page about how to build your own piezoelectric speaker. Obviously, you know, an 8-ohm speaker is going to give you different results, but it's the same principle. Like, mess around with it, and you can change your sound quality pretty considerably, and I think that's cool for, you know, low cost. So moving on from that, so sequencing these sounds. So if you have a cricket that's just chirping like nonstop, that's super annoying, right? You have to sequence them in some way. And this is just like a basic concept of how I do it. You've got to generate a signal, some sort of randomness. It doesn't have to be true randomness. It can be pseudo-randomness. But I like, for example, like a transistor where the base is just disconnected. And then from there, you've got to filter it in some way, right? Because if you look at the noise that comes out of a transistor, it's like, you know, it's sort of like messy and all over the place. You've got to, you know, use like a Schmidt trigger or a Zener diode or charge a capacitor or something to like slow that down and get something sort of resembling a pulse. And then that pulse can be used to trigger a one-shot timer. And you can have a bunch of different one-shot timers that are all like, you know, output a signal for, you know, different lengths of time, and that's how I do it with my birds or my insects. I just set them to different time durations, and then I use those one-shots to turn switches on and off, like a relay, for example. And then the relay turns on and off my individual sound generators. So, you know, pretty straightforward. And this is what it looks like when I build it, and I just think that looks so cool. So, you know, I realize you can do all of this in software, but like hardware is beautiful, and that's something that I really want to get across in my work, is just how gorgeous hardware is. It's magical, it's beautiful, and it in itself, like, it looks like nature, you know, with like vines going everywhere. I think that's awesome. But not all of my work is super chaotic. At the moment, I'm working on a series of large-scale artistic PCBs, so where I take a sound that I know works well and put it into an artfully designed circuit board. In this case, this piece, Pretty Bird, is this PCB is 16 by 24 inches. And it sings like a simple little song, and so this is like a direction that I'm taking my work, you know, as trying to get the fine art world to see how cool electronics can be in a visual art context. But moving back to kind of what, like, my core interest, where I started from the very beginning and where I remain, you know, what is the spark of life? I ask myself that all the time, you know, when I see these emergent behaviors in my circuits that seem so lifelike. It's really like, wow, you know, I mean, how can I say that this thing isn't living? Like, you know, I mean, there's like different criteria people using, like, you know, is it conscious, does it have free will, and so on and so forth. But I mean, you have to admit, it's a slippery slope, right? This is like the coolest slide in my whole presentation, because so I'm going to show you, first of all, I'm going to show you one of my analog electronic songbirds, and the sound that you hear is entirely created by the circuit that's inside of that little mylar body. That's it, okay? It's just an analog electronic circuit that's generating the sound of that songbird. But then on the other side of the screen, I've got some images that I got permission to use from in the top, and you'll see this in a minute, Dr. Gerrit Stuber. This is a video of neurons in the hippocampus of a mouse. Okay, so wait, and I'll show it to you in just a second. But then below that, my friend Ed Boyden of the MIT Synthetic Neurobiology Lab builds apparati that you can mount on a living, moving mouse, and therefore image the neural activity in that mouse, which is what you're seeing in the video in the upper right-hand corner. So let's have a look. So the reason why that birdsong has kind of a more interesting structure is because I have like a large capacitor in there that I'm charging. So it sort of like sings the same way until the capacitor charges and then it discharges and it goes down. But I just think it's so cool that I can get such a complex song with such simple components, and it really makes me wonder, you know, and also looking at this like awesome video of neurons in the brain of a mouse, which is just showing like the voltage differential that's happening across these different neurons. I mean, really, like, are we on the same trajectory here? And I would argue that we are, but I had to put this in my slides because this fabulous painting is here in Los Angeles. And, you know, what Marguerite was trying to say is like, yeah, this is not a pipe, this is a painting of a pipe, and we all know that. But in the case of electronic art, I don't know, it starts to get a little bit like, you know, it's harder to make that distinction because when I make a painting of a bird or a frog, okay, we can say, yeah, that's not a bird, that's not a frog. But when I'm building a circuit that has bird-like qualities, you know, am I getting back to like, is the electricity that's flowing through my circuit, does it have something in common with the neurons in the hippocampus of a mouse, you know? So, you know, people ask me, you know, what is it? It's hard for me to answer when people ask me like, what is it that you're doing in your work? Because like, I'm interested in electricity that's in nature, right? Like, I mean, we are electrical. But I'm also interested in the fact that, you know, nature has these machine-like qualities and that we have these machine-like qualities. So it's sort of this like back and forth. I'm interested in electricity and how it flows through all things, and that hopefully like begins to show us how similar we are to the machines that we're building, and particularly how similar we are to the hardware that we're building. So, thank you very much. If you have questions for me, I'd be happy to answer them, and I'd also love any insights or circuit tips or cool new things that I can try in my designs to get other effects, because as I mentioned before, I certainly do not feel like, I mean, I can't sit down at my bench and just like build any animal sound out there, and I'm always looking for new things to try. So thank you so much.